All right, let's continue our discussion of rates with the Arrhenius equation. So here's the Arrhenius equation. We talked about what the collision theory was conceptually in the previous video. This is a mathematical description of what the collision theory is. So at one single temperature, it's going to give you the natural log of K, whatever your constant is, equals negative EA, the activation energy, over the gas constant R. 1 over T, your temperature is going to be in kelvins, and plus the natural log of A. A is what we call a frequency factor, which just means the amount of collisions that result in a reaction. You can also look at the differences between two Ks at two different temperatures, because remember, temperature completely affects the speed of the reaction. So if we increase our temperature here, we're going to increase our K, our speed of our reactions. Now, that said, now that you've seen the Arrhenius equation, on the AP test, this is actually excluded, and by that, I mean that they're not going to ask you to do a calculation involving these. You will have to know the rest of this, some things we're going to derive from the Arrhenius equation, but you don't need to worry about memorizing the Arrhenius equation. That also said, you do have two homework problems, just so you can get familiar with it. So you have homework problems. Well, not really homework. The class problems, the problem set for 2.3, need this equation. So as you're working those, make sure that you follow these two equations. You can just pull it out. Don't worry about memorizing them. The AP test won't make you calculate, but you are going to need to know this graph I'm going to show you. Okay, so the equation itself is written in slope-intercept form. So the x is going to be 1 over t, and the y is going to be the natural log of k. Let's graph the equation. So the graph will look like a straight line with a negative slope here. Your y-intercept is the natural log of the concentration of A. And your slope is going to be negative, and it makes sense because it's going negative, EA, the activation energy, over your gas constant, R. And this part is going to be important. How is this helpful to find the activation energy, or EA? Well, if you take this, all you have to do is rearrange it to solve for EA. So multiply both sides by R and negative 1, and you get EA equals negative M times R. So EA equals negative M times R. This is worth memorizing. EA equals negative M times R. Because here you can easily find, if you have a line here, you can easily find the activation energy for a reaction from this equation with just your gas constant R. Okay, explain how the following speeds up the reaction using the Arrhenius equation. These are just conceptual questions. When the temperature is increased, so when your temperature is increased, negative EA over RT is going to be a smaller negative number. So if you increase your temperature here, if you think about it mathematically, if this number gets bigger, your overall term, this number is going to get smaller overall. So your overall term is going to be a smaller negative number. So a smaller negative number mathematically works out to increase K. So when your temperature is increased, negative EA over R, that whole term, is a smaller negative number. And then overall, if this whole term is a smaller negative number, then overall, you are going to get an increased K. This increases K. So that's just telling you, just mathematically, why, when the temperature is increased, why does the reaction go faster? Well, because this is a smaller negative number. Adding a catalyst. So adding a catalyst is going to decrease the energy we need for the activation energy. So if we decrease the activation energy, if we make this EA number smaller, negative EA over RT again is a smaller negative number. And if this whole term here is a smaller negative number, again, that's going to increase our K. That's going to speed up our reaction if our K is bigger. So adding a catalyst decreases the activation energy. So again, writing the same thing as before, negative EA over R is a smaller negative number. This increases K. So also, because EA is smaller here, what's this going to do to our graph? Well, our graph is going to have a much less steep slope, so it's going to be a lot flatter looking here. If we have a smaller EA, if our slope is smaller, makes sense, this is going to look flatter. Okay guys, and that is all you really need to know about the Arrhenius equation. So again, remember, you don't need to memorize this, but your homework problems are going to ask you to use it, particularly this one, to compare something with two temperatures, or your problem set, I'm sorry. That's it.